So we're going to move on to the next method, and it is written that tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1 is equals to tan theta plus sec theta. And to solve this math, we are going to need to convert this 1 into sec square theta minus tan square theta equals to 1. And you should practice this math quite well, because while I was like you, I used to make a lot of mistakes in math too. So you should practice this math quite well, and because the process is quite different from the previous maths. So I can write that tan theta. I'm gonna work with left hand side. So left hand side is equals to tan theta plus sec theta minus 1 plus tan theta minus sec theta plus 1. So we need to cancel out the tan theta minus sec theta plus 1, because this is how we can reach the solution easily. And I think we need to memorize the process of solving this math, because this is an exceptional math, I guess. So what we can do is convert this into this 1 into sec square theta minus tan square theta, but we will convert the sec square 1 on the new denominator into sec square theta minus tan square theta, because you will see why we don't do that. So tan theta plus sec square theta minus sec square theta minus tan square theta, and we end up with writing the same thing as denominator, sec theta plus 1. Okay, so now we can split them into using the formula a square minus b square is equal to a plus b into a minus b. So we are going to do that now, and if we do that, you will see that after some time, this part, that is the denominator, will get cancelled out with expression with the numerator. So let me do that. I don't think there will be square here, so I'm gonna remove the square. So I get tan theta. I'm gonna tan theta write the same thing for the first two terms, sec theta minus, and I'm gonna split this term into this form, a plus b, a minus b. So if I do that, I get sec theta plus tan theta and sec theta minus tan theta Okay. So, and I'm gonna write the original denominator again, because I haven't changed anything of this denominator. Tan theta minus sec theta plus 1. So I don't have enough space in the board, so I'm gonna erase all the ink on that slide and move on to the next process. So next part, that is what we had was tan theta plus sec theta minus sec theta plus tan theta into sec theta minus tan theta. I'm just writing the numerator here, because we're actually working with the numerator in this math. Denominator stays same throughout the whole math. So what we can take, we have tan theta and sec theta is here, and we will also have a tan theta plus sec theta multiplied with the sec theta minus tan theta. So we can take both these terms common. So we get tan theta plus sec theta. We write them as common. So if we take this part as common, we should have a 1 before it, because if you multiply this expression with 1, we will get the value without the bracket. So This is the value without the bracket and without the theta, but I'm going to write the theta back. So I have taken tan theta plus sec theta common, and now, so we have a 1 here, we get 1, and we have the minus sec theta minus, I should write with the second bracket, minus sec theta, minus sec theta, sec theta minus tan theta. I am not writing the denominator because it is staying in the original form. I am going to write in the next line. So tan theta plus sec theta, tan theta plus sec theta, we get multiplied by 1 minus sec theta, 1 minus sec theta plus tan theta. And the denominator was tan theta minus sec theta plus 1. And if you look closely, this term 1 minus sec theta plus tan theta is actually equal to tan theta minus sec theta plus 1. The position of tan theta and 1 have been rearranged in the denominator. So we can easily cancel the numerator 1 minus sec theta plus tan theta from both the numerator and the denominator. So I'm going to cancel them all out. Cancel, and cancel these out also. So after cancelling that, we will end up with a tan theta plus sec theta. Tan theta plus sec theta. Tan theta plus sec theta, and this is the required result of this identity. So we can write equals to RHS because we have already reached the form that is equal to the right hand side, and we can write approved. Okay, so this is how we prove the last identity of your 8.2 exercise, and which is an exceptional identity. So I think you should keep the process memorized. Otherwise, if this math comes in your exam, you might get in trouble. And I forgot to write the second bracket here, so excuse me for that. And after that, we'll move on to the next level.